All right, guys, what we're going to do is we're going to do an example problem where we have to do some work, some algebra here in this conic section chapter for a parabola. Now, this is the formula sheet that you're going to need to know in order to answer all the questions I may ask you about parabolas. Everything will come from this formula sheet. But before we do our first example problem, I want to point out one quick thing on here. Please notice that there is a difference, right? In this first column, it is y equals, and it is the x that is squared. That is going to be a parabola that is vertical. Right? That's a parabola that is vertical, simply meaning that it is a parabola that will either open up or down. And how do you know if it opens up or down? Well, remember that's based on the value of a, right? If a is greater than 0, it opens up. If a is a negative number less than 0, that parabola will open down. So if it is y, and then it is the x that is squared, you're going to be vertical. The direction of opening up or down is based on a. The other one, this other column, please notice it's switched. It is now x. X is equal, and it is the y that is being squared. The y that's being squared. Also, please note that k is now inside the parentheses and h is on the outside. That's really important, but we'll get to that in an example problem. This means if it's x equals a y squared, this is going to be a horizontal parabola. And that just simply means that the parabola is going to open either left or right. And how do you know, does it open left or right? Well, again, it is based on the value of a. If a is positive, it'll open to the right. If a is negative, it will reflect and open to the left. All right? So let's go and jump into an example problem now that we know how this chart is set up. Here we go. The first one I've got for you is this parabola. I give you standard form. Please notice it is in the form y equals ax squared plus bx plus c, right? I told you I would give you these equations in standard form. A, b, and c are the constants, 2, minus 12, and 6. But when it comes to graphing a parabola, this is useless, all right? This form is absolutely useless. Yes, it's great for factoring and solving quadratic equations, absolutely. But when it comes to graphing, which is what we're doing, it's less than useless. I need vertex form. My entire formula sheet, this whole thing, is in A's, H's, and K's. I need to know A, H, and K. So that means I'm going to need to go ahead and take this standard form and put it in vertex form, which is going to require completing the square. We'll review that in a minute. Before I do that, though, I can answer this first question, direction of opening. Please notice it is y equals x squared. Well, we just talked about it. When it is y equals and the x is squared, that is going to be a vertical parabola. It'll be oriented around the y-axis, right? Oriented around the y-axis, not if there's a horizontal shift. I apologize, I shouldn't have said that. It'll be oriented vertically. It's either going to open up or open down. How do I know which one? Well, you take a look at the value of a. In this case, it's positive. That's a positive 2 out front. So I know since a is positive, it is going to open up. So I am going to have a parabola that's oriented vertically and will be opening up. So I know that on my formula sheet, I'm going to need to use all of these formulas right here. I don't have this type of parabola, so you just ignore those. Everything I ask you for, the vertex, axis, symmetry, focus, directrix, you'll need to use these guys right here because I have a vertical parabola that is opening upward. We're going to use all these. But in order to use those, I need A, H, and K. So here we go. Let me slide up a little bit here so that I got some space to go ahead and do this. I will rewrite the problem for you. Right here, I have given you y equals 2x squared minus 12x plus 6. Okay, when it comes to completing the square, there were two ways to do this, two ways to complete the square. Now, the way that we can't use here was this. If I had some number over here, if I were to subtract, that's not even going to be what I want to do. Okay, there were two ways to do it. If this quadratic equation were equal to some other number, when I add something, in this case b squared over 4, I'm getting ahead of myself. Let's just review how we do this. this is y equals. I'm going to have to graph it. It's a quadratic function, okay? I can't add anything to this side. In order to graph something, it has to be y equals. It can't be y plus 6 equals or y minus the square root of 3 equals, right? It has to be y equals. So I need to keep this y by itself. What that means is that in order to complete the square, I must do all of my work on this side of the equal sign. It's all going to be done on this side, all right? So here we go. Let's go ahead and complete the square. Now, remember, in order to complete the square, what we're going to do is we're going to go ahead and take our x's and put them inside of parentheses. I'm going to create a space where I can work in order to complete the square, right? So I'm going to take that 2x squared and the minus 12x, all right? And those are the guys, I want to complete the square for these guys. And so I'm going to create a space, like a workshop where I can complete the square. But that 6 is not needed, so he will just leave him outside the workshop. I don't really need him right now. He can just hang out there. Now, in order to complete the square, I need this leading coefficient to be a 1. You should remember this from chapter 4. That leading coefficient needs to be a 1. So what do I need to do? Well, I'm going to need to pull that 2 out. But you got to be really careful. I can't just pull a 2 out of this 2x squared. I must also then pull a 2 out of this 12. So here's what's going to happen. I pull out that 2. That's going to leave me with an x squared, negative 12 divided by 2, right? I pull a 2 out. That's going to leave me with a minus 6x. Fantastic. All right, so here's what I've done. I've created my workshop, that little space where I'm going to complete the square, and I've done all sort of like the preliminary prep work, right? In order to complete the square, that leading coefficient needs to be a 1, and that's exactly what I've done. I pulled that 2 out, and so now I'm all set. Inside of my little workshop here, I'm ready to complete the square. And remember, the way that you complete the square is by adding b squared over 4, right? That's how you complete the square. And that's my b, right? That's going to be my b right there. So here we go. Complete the square. Y equals 2x squared minus 6x. I will add a b squared over 4, right? So that's going to complete the square inside of my little workshop, right? I've got to complete the square for this trinomial by doing b squared over 4. We'll come back to that in a second. Then on the outside of my workshop, well, here this is where I got to take care of the algebra, right? There's a lot of rules you got to follow in algebra, and it's now time for me to sort of kind of pay up, right? Here's what I did. I've just added sort of willy-nilly inside my workshop a b squared over 4 to complete the square. But in order to kind of reconcile everything with the algebra, remember, algebra says whatever you do to one side, I added a b squared over 4, you have to do to both sides. But I don't want to add a b squared over 4 on this side, because then I would have y plus b squared over 4. And I can't graph that. In order to graph it, it's got to just be a y equals. So what am I supposed to do? If algebra says whatever you add to one side, you got to add to the other side, but I don't want to add b squared over 4 to the other side, what am I supposed to do? Well, here's what we're going to do. Since I added b squared over 4 inside the parentheses, just subtract that b squared over 4 on the outside of the parentheses, right? So I'll add the number inside, subtract the number on the outside, and as far as the algebra is concerned, we have balanced our equation, right? I added a little bit inside the parentheses, but I subtracted that little bit on the outside of the parentheses, and it brings my equation back into equilibrium. But there's one last trick, hopefully you remember from chapter 4. Please notice that when I I subtract that b squared over 4 on the outside. Added it inside, subtracted on the outside. There's one last thing you got to remember. Please notice that my b originally, right, this was the value of b, a, b, c. This is my b. It was a minus 12. But I pulled a 2 out of that original value of b, right? I pulled out a 2, and now I have a b of negative 6, which that negative 6 is the b I'm going to use, right? I'm going to do a negative 6 squared and divide by 4, right? And I'm going to negative 6 squared and divide by 4. I'll add it in here, subtract it out here. But what about that 2 that I pulled out? Well, hopefully what you'll remember from chapter 4 when we did this completing the square, you have to remember to put that 2 back, right? That 2 that I pulled out over here, right? I pulled that 2 out to give me the negative 6. That 2 right there, I got to put it back, right? I got to put that 2 back. So we're going to multiply that whole thing by 2, right? Since I divided a negative 12 by 2 to get the negative 6, when I do my b squared over 4, I'm going to multiply it by 2 to put that 2 back in there that I had originally pulled out. So anyway, there we go. As far as the algebra is concerned, I'm completely reconciled. I've added b squared over 4 on the inside of the parentheses, subtracted it on the outside of the parentheses, and please keep in mind, watch, right? The algebra says I need to be balanced out, right? It's got to be balanced. Well, if I were to distribute the 2 through the parentheses, please notice I would wind up with a plus b squared over 4 times 2. That's inside the parentheses. And on the outside the parentheses, I have a minus b squared over 4 times 2. The plus b squared over 4 times 2 and the minus b squared over 4 times 2 would cancel each other out and get me right back to where I started. So as far as the algebra is concerned, I'm perfectly okay. Add it inside, subtract it outside, and don't forget to put back what you pulled out. Whew. All right, here we go. What is b squared over 4? Well, b squared over 4, my b is a negative 6, so I will have to square, right? Square negative 6. Negative 6 squared is 36, and 36 divided by 4 is 9. So I will add 9 on the inside. On the outside, I will subtract 9, but I'm going to multiply that 9 by 2 to put back the 2 that I pulled out. Again, please notice, if I multiply this 2 in here, I'd wind up with a plus 18. On the outside, 2 times 9 is a minus 18. Plus 18, minus 18, cancel each other out. I get right back to where I started. That's how I know the algebra has worked out. I haven't broken any rules in algebra. All right, keep going. Y is equal to, now, this is a perfect square trinomial, all right? That's why we call it completing the square. You have now completed the square and created a perfect square trinomial, which are the easiest things in the world to factor. They're going to factor every time, nice and easy, and they have to factor into the exact same thing. These two binomials must be identical. It's a perfect square trinomial. Well, two things that multiply to x squared, x and x. I need two numbers. They have to be the exact same number. Those same numbers must multiply to 9 and sum to a negative 6. And of course, that's a minus 3 and a minus 3. And I feel really good. X minus 3, x minus 3. That's how it works. It's a perfect square trinomial. It must factor into two binomials that are identical. If it doesn't, you goofed. Go back and figure out what went wrong. Out here, plus 6, minus 18. So, last step. I have two of them, x minus 3 times x minus 3, which would just simply be the quantity x minus 3 squared. And then, of course, plus 6 and a minus 18 should be a minus 12. And cuckoo, cuckoo, you have vertex form. There's my A, there's my H, and there's my K. So A is equal to 2. H is equal to, keep in mind, remember that we have to switch H, the horizontal transformation, you have to switch the value of H. Since it's a minus 3, I will have a plus 3. And my K, the vertical shift, is minus 12. Now that I know A, H, and K, I can go back to my formula sheet and answer all of those questions that I have up above for you guys. So we'll go ahead and take these values, and in the next video we'll go through that formula sheet, show you how it works to answer all of the questions. But this is the algebra, right? Complete the square to go from standard form to vertex form to find A, H, and K. Once I know H and K, it's going to be plug and chug using that formula sheet to answer all the questions. I'll meet you guys there.